Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for the last official lesson of the school year. The M&Ms for this particular lesson are officially getting into your notes what we do when we're trying to find the volume of a prism. Not all prisms are going to be rectangular prisms, so knowing that you multiply these three numbers together is not going to work anymore. It'll work with a rectangular prism, sure, but it's not going to work for any prism that has a different base other than a rectangle. If this was a triangular prism, then the area of the base would have the triangle area formula, which would be 1/2 times base times height. If it was a trapezoid, it would have that trapezoid formula. If it's a circle and it's a cylinder, then it would have the area of a circle formula. So in essence here, you just decide what is the base, and if it's a rectangular prism, it can be any one of the sides can be considered the base because they're all rectangles. But whenever it is anything other than a rectangular prism, the name of the base names the prism, and you'll have to use the formula or figure out the area of that base. So here are some different examples. This is an example of a prism. It's a triangular prism. So you would, if you wanted to figure out the volume of this prism, you'd have to find the area of this triangle and then multiply it times the height, which would be the distance between the two triangle bases. So yes, this is definitely a prism. This is not a prism. This is a pentagon, which is two-dimensional, so that's a polygon, not a prism. Technically, this is not a prism, although the formula you're going to find in 8th grade is exactly the same as the formula for finding the volume of a prism. So the cylinder and the prism are related, but because it does not have a polygon for base, it's technically not considered a prism. This is a prism, and I guess technically we would call that a hexagonal prism since the L shape is a 6-sided polygon. So yeah, that's definitely a prism. So you would figure out this is like that Laverne's dessert kind of a problem where you find the area of the base and then multiply it times the number of layers. So V equals capital BH works for A, C, and D as far as finding their particular volumes. All right, so now let's put that into practice. Find the volume of a 1-unit high layer of each prism, then find the total. Okay, so for this one, which one do you want to have be the base? Do you want the 10 by 10 to be the base, or should we have the 50 by 10 be the base? So I think it's probably just easiest if you have the base be the top and the bottom. So this is the base, and the dimensions of this base are 50 by 10. So if we just take this one layer off of that base, there would be a total of 500 cubic meters in that one layer. And how many total layers are there? There's a total of 10 of them because that's the height. So for this formula to take the base area times the height, in this case, since it's a rectangle, the base area is going to be base times height of that rectangle. So that is 50 by 10, and then multiply it again times the height of the prism. And I know it gets confusing because here is the height of the 2-dimensional polygon, whereas that's the height of the 3-dimensional prism. It gets kind of confusing sometimes. You just gotta, maybe if we call this height 1 and height 2 or something like that, maybe that would make it better. But either way, that's how you find the volumes. Then it says to find the surface area. So to find the surface area, the top was 500, and it looks like this is 500. So the bottom and the back are going to be 500 as well. So you've got 4 sides that are all 500 square meters for their areas. And then you got this right side that's 100, and then the left side will be 100. So you'll have 2 sides that are 100 square meters. And so that's how you get 4 times 5 is 2,000, and 2 times 100 is 200. So you get a total surface area of 2,200 square meters. All right, on to the triangle-based prism. So once again, volume is going to be the base area times the height, but in this case, your base area is a triangle, so we're going to take 1/2 times base times height, because that's how you're going to find the area of this triangle, and then multiply it times the height, which is basically the distance between the two triangle faces, if you can picture the one on the bottom that you can't quite see right now. So we're going to take this first layer. Well, no, let's find the area first. So what are the dimensions? The base and the height of the triangle, remember, form the right angle. So this is 9 and this is 9, which means you're going to have to take 1/2 times 9 times 9. And then that's going to give you the area. What's half of 81? 40.5. So if you took one layer, 1 centimeter layer from that base, you would have 40.5 cubic centimeters in there. Now for the height, for the volume, you're going to multiply that times 8. When you take 8 times 40, that's 320, and 8 times 1/2 is 4. So 40.5 times 8 is going to be 324. So that's the number of total cubic centimeters that would fit inside this triangular prism. Now, we saw that the area was 40.5, correct? And you had an area on the top and on the bottom. So put those together, that makes 81. Now let's take the dimensions of this side. This is a 9 by 8, so this is 72. This is a 9 by 8, so that's 72. So you put those together, and I think that's 144. So we've got a total of 1, 2, 3, 4 faces so far. Now the back one, what are the dimensions of the back face? 12.7 centimeters this direction and 8 centimeters this direction. So let me put this in there again. Get rid of the 72s, and that would be the back rectangle face. So I don't know what that is, so I'm going to use my calculator. 12.7 times 8 is 101.6. Stop it. 101.6, and so let's put in our decimal points and our zeros. So it's going to be a 6. That's going to be a 6. That's 12. Carry the 1. That's a 3. So you get 326.6 square centimeters is the total area when you add up all the areas of all the polygon sides of this triangle-based prism. All right, so here is a hexagon. No, it's not. It's a pentagonal prism because the base is a pentagon, right? 2 bases, they're parallel to each other, they're separated by rectangular faces, so that's a prism. If the prism were sliced vertically, if you went straight down, this is what it would look like, and you would have basically sketch the resulting cross-section. I guess the cross-section would be a rectangle. It's kind of hard to see it, but what do you call each one of those? Those are just quadrilateral bases, right? So I don't know if there's any name you could technically give for each one of those prisms. There probably is. It just, I don't know what it is. But yeah, the face that is right in here where they got cut, going straight down, those would be rectangles. If you cut it horizontally, they're going to look like this. And so this would be the surface of where it was cut. And so that would be a pentagon face. Find the area of the circumference of the circle that has a diameter of 17 millimeters. So we're going to find the area of this circle. So remember, if the diameter is 17, the radius is going to be equal to 1/2 of the diameter. So we're going to cut 17 in half, so it looks like the radius is equal to 8.5 millimeters. Since we use pi r squared to find the area of a circle, we're going to square 8.5, then multiply it times pi. And, you know, you could do this in your calculator. 8.5 squared. Wait, stop it. 8.5 squared is 72.25. Then multiply it either times 3.14, or if you hit the pi button, then your answer would have been 226.98, which might have rounded up to 227. Which that rounds up to 227 as well. So we're not too far off by rounding pi off to 3.14. Now for the circumference. When you find the circumference of a circle, you may recall that the circumference is a little bit more than 3 times the diameter. If the diameter is 17, if you multiply 17 times 3, you get 51. But technically, it's pi times the diameter, and so you get 53.38 or something close to that, depending on, let's go ahead and use the calculator. 17 times pi, stop it. 17 times pi, stop. 17 times pi, there you go. 53.4 53.38, that would round to 53.4. So yeah, we're pretty much good with our round off there as well. A bag of margables contains only colors red and green. If the probability of getting a red marble is 1/3, what's the probability of getting green? Well, it only has red and green. So if 1/3 of them are red, then the others, which would be 2/3, would have to be green. If there are 24 marbles in the bag, how many are green? Well, it's a 2/3 probability, which means that 2/3 of the 24 are green. So you're going to multiply 2/3 times 24, and you get 16 for an answer, which means the rest of them, 1/3, there must have been 8 of the red. What is the probability of drawing 2 marbles that are red? Note, the first marble is not replaced. Ooh, that changes our probabilities, okay? So we know our probability of getting a red is 1/3, which is the same as 8 out of 24, correct? So if you took one of those out and didn't replace it, then now you've got 7 out of 23. So in essence, what you're going to have here is you're going to take the 1/3 was the original probability, multiply it times the 7/23, because when you are dealing with a situation where you've got compound probability and you do one thing and then you do another, that is a multiplication process. Remember, when we use the word and, that meant we multiplied. When you use the word or, getting a red or a green, then you add the two probabilities together. But you're pulling out two of them, so you got to pull out a red and then another red without replacing the first. So we have to multiply the probability of the first one times the probability of the second one, and then you get your 7/69, which to convert that to its percent, you could use the percent proportion, or some of you just take the fraction 7 divided by 69 and then convert this decimal number to a percent by moving the decimal 2 places to the right. So that's like 10.14 or just 10.1%. I just rounded it to the nearest 10th of a percent. What's the probability of drawing 2 red marbles if the first one is replaced? And so, all right, so same idea here, but instead of not putting that red marble back in, you put it back in. So we don't have a situation where we're reducing the number of red marbles and the number of total. So every time you pull it out, it's still a 1/3 probability, and that's how you get the 1/9. All right, and then I feel like it's been a long time since we've done a checkpoint problem. At this point in 7th grade, it is expected that you understand how to do proportional reasoning and work with unit rates. So Tina drove 108 miles and used 4.5 gallons of gas. What was her miles per gallon? So if you take this and write it as a ratio of 108 over 4.5, that will be equal to X over 1 gallon. Okay, so take 108 divided by 4.5 and you get 24. So she must be getting 24 miles to the gallon. So that would be the unit rate. And if we wanted to put this now into an equation, X being the number of gallons of gas that is consumed and Y being the total of miles driven, you can plug in any number of gallons and figure out the number of miles you could go. For instance, if your car holds 15 gallons of gas, how far can you go on 1 gallon? 24 times 15 will give you that answer. All right, now moving on to B. If 17 oranges cost $3.23, how much does each orange cost? Okay, so $3.23 for 17 of them. How much is it going to be for 1? Go ahead, take this number, divide by 17, since that's what you would do with your giant 1, and you're going to get your unit rate. $3.23 divided by 17 is indeed 19 cents per orange. So here, Y equals 0.19 times X, where X represents the number of oranges that you're purchasing, and Y represents how much the total cost is going to be. So any number of oranges, you can figure out the cost by using this equation. Here, you might decide actually to simplify that ratio to 2 over 3, so it becomes a little bit more obvious. Your giant 1 is a 4, so 2 times 4 is 8. If you didn't want to do that, you could always cross multiply. 40 times m is going to be equal to 13 times 100. So now we just have to divide both sides by 40 because that's what we do when we're solving a one-step equation. 40 times m is 1300, so 13 divided by 40 will tell you what that m is, and that's where you're going to get 32.5. So a few different strategies can be used for proportional reasoning. One of them is finding unit rates. Other situations, you can look for giant ones or cross multiply and use algebraic reasoning to solve. All right, congratulations. We only have a study guide to complete, or maybe 2 study guides, and the chapter test on Friday. But we are done with our traditional lessons and homework for 7th grade. Take care.
Hey, feeling good.